What's up, sports fans? Let's work through applying angle relationships. I'm going to work through this entire front page, and I'm also going to be using the previous set of notes with all the parallel lines and transversals and all these angle relationships. If you do not have this out, please get this out now. This is the page I need you referencing a lot. I don't need you to memorize these things. That's silly. If you don't have this completed, please make sure it's completed. It's in the everything doc. You can also pause this thing here if you need to, all the information. Okay, let's get that off the screen. All right, applying angle relationships. So we can use our knowledge of angles formed by parallel lines and transversals to find missing measurements. Well, what is our knowledge of the angles formed by parallel lines and transversals? It's that page I just showed you. That's our knowledge. Make sure you have this page in front of you. I don't need you memorizing that. Math class, not memorize class. So in the following examples, we're going to write and solve some equations to help us find missing information. So here we go. We're going to blend in some algebra in the midst of our geometry class. Here we go. Problem 1. Elm Street is parallel to Oak Street. Pause. Let's identify. Elm Street is here, Oak Street is here, and they are parallel, so they'll never touch. Okay. Cedar Drive cuts diagonally across the two streets. Cedar Drive cuts diagonally. Oh, okay. That'll be our transversal. Find the measure of each marked angle. Okay. Well, I'm seeing an angle here. That's 3x plus 103. And I'm seeing another angle here that is 9x plus 61. Don't get caught up in the details right now. I'm just going to call them red angle and blue angle for the moment. And let's see what we can figure out. So we have a know and need to know question or little boxes here. Here's where we're going to craft our plan and show some work. And then here's where we're going to demonstrate our solution. So what do I know about these two angles? Again, forget about the x's, forget about the numbers. I'm purely looking at the location of which angles we're interested in. So I'm noticing that this one is on top of its parallel line, this one is on top of its parallel line, and they're both on the same side of the transversal. So when I look at my notes, it appears to me that these are angles in the same relative position or they have matching corners, just like angle A and angle E or angle B and angle F. So these are corresponding angles and their relationship is that they are congruent. Congruent means they have the same angle measure. So what do I know about this situation? I'm going to say these angles are corresponding and must be congruent. These angles are corresponding and must be congruent. Okay, what do I need to know? Well, I need to find x, value of x, so I can substitute it in to find angle measures. I need to find the value of x so that I can substitute that value of x into red expression and blue expression so that I can find those angle measures. Okay, well, this piece right here, bigly important, congruent. That means red angle and blue angle have the same exact measurement. What that measurement is, I don't know yet. That's the whole objective of this problem. But what I do know is that I can create an equation, and that equation is red angle equals blue angle. So 3x plus 103 equals blue angle, which is 9x plus 61. Great, now I'm going to solve this thing. There's only a single variable. I mean, it's chopped up. There's a little bit on both sides, but there's only a single variable. This is great news. So what I'm going to do is I'm going to gather all of my variables on the left-hand side. That's just my style. You can gather them on the right if you want to keep them positive. That can be your style, no problem. So I'm noticing that this 9x, it's positive. So if I want to undo that, I need to subtract 9x. So, 96, what in the world? 9x. And then we'll learn that negative 6x plus 103 equals 61. Great. I'm now going to subtract 103 from both sides, where we will learn that negative 6x equals, 61 minus 103. I don't know. Let's grab my calculator. 61 minus 103. Calculator says it's negative 42. Super. I'm going to draw an arrow now, point this right up here, and rewrite just so I have more space to work with here. I don't care what negative 6x equals. I care what 1 positive x equals. So this just reads negative 6 times x. If I want to undo that, I'll divide by negative 6, divide by negative 6. Negative 6 divided by negative 6 is 1. 1 times x is x. Now I'm interested in what this side is going to be. Negative divided by negative is positive. 42 divided by 6 is 7. So here's my claim. My claim is that x equals 7. I'm not done yet, though, because the goal is to find the measure of each angle. I found x. I didn't find the measure of each angle. So now what we need to do is substitute it in to find the angle measures. All right, red angle first. 3x plus 103. That's our given x measurement. Well, I know that x is 7, so this is 3 times 7 plus 103. 3 times 7 is 21 today. And 21 plus 103 is 124 degrees. So my claim so far is that x equals 7 and that red angle is 124 degrees. But I'm not done. I need to show that blue angle has the same measurement. If I get a different result here, something went sideways, and I have to go figure out what that something was. So playing the same game, 9 times x, which again, I'm claiming is 7, plus 61. Let's see what we get here. 9 times 7, that's 63. 61 is still 61. 60 plus 60 is 120. 3 plus 1 is 4. So this also equals 124 degrees. So our solution here, find the measure of each marked angle, they are both 124 degrees. That's good news. We did it. Let's move forward. Question number 2. Question number 2. Here we go. The side view of a table is shown, and the top of the table is parallel to the floor. Okay, picture this. I know it's not a perfect picture. This is the top of the table. This is where, I don't know, your plates and stuff are, and there's, I don't know, it's Thanksgiving, so you have candles and things going up here. So this is our table. Here's the floor, and then it's got these legs in like a crisscross type of pattern here. Okay, so we have a couple angle measures here. Let's do the same thing. I have red angle and I have blue angle. So far, I don't care what the measures are. I mean, ultimately I do. That's the goal of the problem. But I'm not there yet. I'm not trying to think that far ahead quite yet. So what do I know? What do I know about the relationship between where these two angles are? Well, this one's almost a little tricky because we have two different transversals. We're used to seeing stuff like this, two parallel lines with transversal going through the middle. Well, we actually have that here. It's just a little bit sneaky. So our transversal that we are going to acknowledge is, let me grab a highlighter to kind of demonstrate this, is right here. It goes like this, pretend that's a straight line. And then here are two parallel lines. So now if you just focus on the two parallel lines and the transversal that I drew in the pink highlighter, my hope is that you see that these two angles we're interested in are on the inside of the parallel lines, and they are both on the right side of the transversal. So what relationship must these have? I don't know. Let's check our notes. Which of these, well, they're inside the parallels, so it's one of the interior ones. They're angles inside the parallel lines. And here we go. This one is inside the parallel lines. But this one says it's on opposite sides of the transversal, so it's not that. It must be this. Angles inside the parallel lines on the same side of the transversal. That's what we have. So we have same side interior angles, and their relationship is that they are supplementary. Remember that supplementary just means they add up to 180 degrees. So what do we know? We know that these angles are same side interior angles so they are supplementary. They are supplementary because they are same side interior angles. What do I need to know? Just like before, the value of x. So I can sub it in to red and blue, let's say expressions. You can just say sub it in to find angle measurements. That's over the top. It's true, but it's over the top. Okay, let's make a plan and show our work and stuff. Now, here is the single biggest mistake that I see in this unit every year I've ever taught it. So this is year like 5 teaching geometry. So I see this all the time. It's pretty easy to set two things equal to each other and solve. Some people just always, whenever they see expressions, they'll be like, oh, red stuff equals blue stuff. Let's set them equal and solve. That's not always true. It's true if the angles are congruent. It's true if they're corresponding, but that's not always the case. Sometimes they're supplementary, like for us. Again, notice in this chart, all the relationships are either congruent, or supplementary. So we have to pay attention to if they're congruent or supplementary. If they're congruent, set them equal to each other like we did in number 1. If they are supplementary, don't set them equal. We add them together and set them equal to 180. So I'm going to say red stuff plus blue stuff equals 180. I still don't know the value of x. I still don't know the angle measure of red or of blue. That's what we're trying to figure out here. But what I do know is that if you take red stuff and add it to blue stuff, it definitely equals 180. Okay, let's solve. How many x's do we have on the left-hand side? I see 21 red ones and 4 blue ones. Oh, hang on. I see 17 red ones and 4 blue ones for a total of 21. Getting ahead of myself. -9 is still -9. And on the right-hand side, 180 is still 180. Solving for x, we can do it in 2 more steps. Let's add 9 to both sides to get rid of this constant here. And then we see that 21x equals 189. I'm now noticing this is 21 times x, so let's divide both sides by 21. And I don't know what 189 divided by 21 is. So let's ask our calculator friend, and we learned that it's 9. I'm really glad to see it's a whole number. This is good news. So x equals 9. Now, again, that is not the ultimate goal. We are not done. It says find the measure of each marked angle. We found the value of x. So same, just like before, red expression here, 17x minus 9 is 17 times 9 minus 9. Well, 17 times 9. Again, I don't know. 17 times 9. 153. 153 minus 9. And 153 minus 9 is 144 degrees. So far, I'm claiming that red angle is 144 degrees. Let's make sure that makes sense. Blue angle needs to be supplementary to this. Otherwise, we've run into a mistake. So blue angle needs to be, well, what is it? What is 180 minus 144? Oh, that's 36. So blue angle needs to be 36. If it's anything else, we've made a mistake somewhere. Let's find out. Blue angle is given to us as an expression of 4x. We think that x equals 9. So let's see, 4 times 9. Well, 4 times 9, that is 36. That's good news. That's exactly what we hope to find. As a refresher, 36, there it is. We got 36. So our solution here is that red angle has an angle measure of 144 degrees, whereas blue angle has a measure of 36 degrees. Okay, use these as examples, reference them early and often. Also reference this sheet here. Without this one, you are working way too hard. Please have this out in front of you as you practice these. There are some other examples and whatnot here. I'm not going to go through these in this video. It's already getting woefully long, but what I will show you is a few solutions, and you can go ahead and pause and take what you need from this here. And that's the end of our video. Have a great day.